the Thevenin's theorem, how to solve the circuit using Thevenin's. So this is the circuit with a 15-volt source. There's only one source. So first step is you need to find out VThevenin, and then you need to find out RThevenin. You can either find RThevenin first or VThevenin first. It doesn't matter. So whatever you are convenient, you can find one thing. So let's start with VThevenin first. So to find VThevenin, the rule is to remove the load resistance and redraw the circuit. Since there is only one voltage source, so I will redraw the circuit. 15 volt, 3 ohm. This is the point where the load was connected. So this represents my A and B point. So the point where the load is connected, you remove the load and the voltage that is measured across point A and B will represent VThevenin. So let's label this resistors. This is R1, R2, and R3. Now, due to this 15 volt, there will be current flowing through this. So VThevenin is the voltage that is appearing across point A and B. So when you put a meter across these two points, A and B points, when you put the meter across point A and point B, the voltage that appear across A and B will represent VThevenin. So you need to find out VThevenin. So since this is open here, so current that flows through 5 ohm is 0. Since the current is 0 here, that means voltage across 5 ohm is 0. So I can ignore this thing and I can redraw this thing with, let me highlight this. So this can be ignored, 5 ohm, because current is 0, voltage across 5 ohm is 0. So this can be like this, right? You just simplify circuit. So now there's nothing in between. So this can be my A point and this can be B point. So voltage across A and B point is VThevenin. That means the voltage across resistor R3 is VThevenin. So you need to find out voltage across resistor R3 that will be same as VThevenin. So that means Ohm's law, current flowing through R3 times R3. So see here, this is the current flowing through the circuit. And then this current goes here. Whatever current is here, I will go here. There will be no current flowing in this 5 ohm because it's open. So the whole current, the same current flows through the circuit. So same current is flowing through this whole circuit like this, right? So 3 ohm and 2 ohm, they are in series because same current flows through both. So since they are in series, the total current will be total voltage divided by total resistance. Total resistance is the resistance that you will measure across point C and D, that you measure across the voltage source. So when you measure the resistance across the voltage source, you're putting the meter leads here, and you will go from here and towards the meter. So R1 and R3 are in series. So total resistance here will be R1 plus R3. They are in series. That gives you 3 plus 2, 5 ohm. And V total is 15. 15 divided by 5 gives me 3 ampere as current. Now 3 ampere is the current that flows through 2 ohm resistor. So VThevenin will be current flowing through 2 ohm resistor time the resistance R3. That is 3 ohms multiplied with 2. That gives me 6 volt as VThevenin. We have found VThevenin. My next step is to find RThevenin. Now to find RThevenin, I have to redraw the circuit. So to redraw the circuit, the rule is when you're finding RThevenin, any voltage source is considered as short and any current source is considered as open, and you redraw the circuit. So I'm redrawing the circuit. The load RL is considered as open. So you put the ohm meter across A and B. The resistance that will measure across point A and B is your RThevenin. So when you're putting the ohm meter across A and B, your measuring resistance R Thevenin. So you will start from here and go towards there, the measuring point. So this is my R1, this is R3, and this is R2. So first you solve R1 and R3. R1 and R3 are in parallel. So R13 will be R1 parallel to R3. That gives me 3 times 2 divided by 3 plus 2, 6 divided by 5. So let me do the math here. So 6 divided by 5 gives me 1.2. Now you solve this portion here, the parallel combination. So the resultant, if you redraw the circuit, it will look like so this is your R13 and this represent your R2, right? So let me make it with different color so that it's not confusing. So this represents R2 and this is your R13. So now R Thevenin will be R13 plus R2 because both are in series. So that means 1.2 plus 5 gives me 6.2 ohm. This is your R Thevenin. So the next step is to draw equivalent circuit for V in Thevenin's theorem. So V Thevenin goes here, R Thevenin in series here, and RL in here. So this is your equivalent circuit. So you have already found the value of V Thevenin and you have found the value of R Thevenin and you redraw the circuit. This is how you make the equivalent Thevenin circuit. Thank you.